Right, you lot. Welcome to the second day of C++. I think introductions aside, you already know what we're going to do. You already know what we did yesterday. So as a continuation for today, let me first start by introducing myself. My name's Taki. I'm the previous president for GDSC USM. I've been working in C++, particularly teaching it for the past, God knows when. Let me just be clear enough and say 3 years. Past solid 3 years. I've been teaching it for the past 3 years. So I kind of know where you're going to trip, in a sense. I kind of know the difficult topics that you're going to be facing. And one of them is definitely pointers, which we're going to touch on right about now. So a quick question before we actually start in the chat. Do you have any idea what pointers are? Like any idea at all? Just put it in the chat. I'm listening. Go on. I'm all ears. What is it? Yeah, I know. If you do know what it is, tell me. Tell me in simple words. Go on. Like what do you think about when you hear the word pointer? What is it that comes across your mind? I think they're having a food coma or something. No, they're not. Oh, they're here. Thought you were dead. Pointer to address of something. Fair enough. Use it to point to a variable. Fair enough. Refer. Good enough. Accurate. It points to the address of the variables. Fair enough. So from the question, from the answer that I just get, there's one thing that you lot have to understand, and there's one thing that I always say whenever I teach anything, really, not just C++. Whenever I teach anything, I always stress and I always tell people to focus on the definitions. The definition is pretty much everything. Like whenever you're stuck, you go back to a definition and you should find the solution, whichever problem you're facing. So if I were to define a pointer for you, the first thing that I have to define is what it is, like the what. And a pointer is pretty much a variable, just a variable. That's it. So if you were to summarize everything, if I were to summarize basically the definition in what we call a points, yeah. Let me just remove this real quick. We're no longer saying hello, we're digging in. So come on, give me the draw. Thank you. So a pointer is pretty much a variable. Okay. So if it is a variable, what do you understand? If I tell you, for example, something is a variable, the very first thing that you understand is that the rules of the variables that you learned yesterday, they apply. Rules apply. So if the rules of the variables apply, so they must be stored. I must be able to perform operations on them, perform operations. And one of the operations is arithmetic. I should be able to perform arithmetic. I should be able to perform bitwise. I should be able to perform conditions on them, and just about everything. Since we assign the characteristic of being a variable, so it should be able to have the characteristics of a variable. Now, are there any exceptions? I'd say no. No exceptions. You can perform anything, just like a variable. Treat it as a variable, literally as a variable. Now, we know the different primitive types of variables. Yeah, you learned them yesterday. Integers, characters, booleans, floats, doubles. Each variable holds a particular type of data. For example, integers, an int, it holds integers. A float, it holds decimal points, floating point numbers, etc., etc., etc. Now, what does a pointer hold? The pointer holds an address, literally an address. Now, what on earth is an address? All right. Let me go back to basics a little bit. Where does the computer store data? Where does it store them? Anybody has any idea? Where does computer store data? You there? You dead or alive? Precisely, in the memory. Now I'm going to go there and stick an R into it, and that's going to be a RAM. Now, a RAM, you can understand it as some kind of a closet. It is literally a closet. It's got loads and loads of rooms in it. Well, I'd say a hotel, but a closet. Same thing anyways. So it's got basically a bunch of rooms in it. There it is. Now, each room is labeled. For example, this is labeled room number 1. This is labeled room number 2, number 3, number 4, number 5, etc., 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 etc. Now, these labels are addresses. So so basically, a pointer is a variable that holds an address. And what's this address? It's a place in memory. It's just a place in memory. That's it. That's what it is. It's just a place in memory. Now, one thing that that a pointer has, so kind of a special thing to a pointer, is the way it's declared. The way a pointer is declared is different than a normal variable. Now, if you want to declare a variable, you'd basically say type name, and you basically set it equal to something. Now, since a pointer is a variable, it must have a type. Yeah, that's one of the characteristics of a variable. In C++, in order for you to have any variable, you need to have a type for it. Otherwise, you can't really declare a variable in C++. So same as a variable, a pointer must have a type. So that's literally my type. And in order for me to tell the compiler that this is a pointer and not a normal variable, I'd stick an asterisk in there. This star thing, an asterisk, give it a name and assign it. Now, how do I assign it? How do I assign it? Assign it to what? I don't know the memory addresses. If you've got 16 gigabytes of RAM, God knows how many memory addresses you have. You have a lot. And a memory address looks something like this: 0x00001. That's literally this one. 0x002, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10. You see, it's coded in hex. Now, how do I know how to assign a pointer? Now, let's just go back a little bit. Let's just go back a little bit to some of the basics. Up until now, do you have any questions? No. Good. If you've got any questions, please just talk. Just say something, just so I know that you're there. All right. So we stopped at how do I know where to how to assign a how do I know how to assign a basically how to assign a pointer. Now, what we can do theoretically, what we could do is that we would have our type, yeah, have our name, and set it equal to the memory address that we like, 00x001. We would like to do this. However, due to the complications, we can't really do that because we don't know if this address is vacant or not. Who knows? Who knows this? Who knows if a memory address is available for use or not? Can you give me a guess? Who knows? In the computer system, who knows? The CPU doesn't quite know. The CPU just uses stuff. I'll tell you who knows. Mr. Windows or Linux or Ubuntu, whatever you're using. I'm using Windows, so I'm going to use Windows. Mr. Windows knows that a particular memory address is used or not, the operating system in general. The operating system knows. So we need to somehow, the operating system, we need to somehow get him to tell us which memory address is used or not. Yeah. And C++ made it easier for us. In order for us to get the memory address, we have something called an ampersand, which is this little thing here. Where it is? There it is. This little thing here. This ampersand. This is what we use to get the memory address of any variable, really. So if you have a variable, let's say int name is equals to 1, what we can do, I'm going to leave this in red, but I'm going to change this to black. Type ptr coordinate pointer. You stick this ampersand in, and you say the name of the variable name. Here is how you assign a pointer. However, we have a missing part. What's the type going to be? Anybody has any guess what the type should be? Any guess at all? Any guess at all? Come on. No, it's not a string, matter of fact. It's an integer. Why is it an integer? One of the characteristics of a pointer is that the type of the pointer should be the same as the type to the type of the thing that's pointing to. So if it's pointing towards an integer, the type of a pointer should be an integer. If the pointer, what I mean by point to, yeah, if I say, for example, point to, if a pointer points to a variable, it basically means that this pointer holds the memory address of this variable. So if I say, for example, pointer points to name, it translates as pointer holds the memory address of name. Is that clear? Should be. So the pointer should have the same type as the thing, or as the variable, or as the memory block. Listen to this carefully. I said variable and I said memory block. This is really important to keep in mind. A memory block. It should it should have the type of the same of the memory block that it's pointing to. So if it's pointing towards an integer, it should be an int. If it's pointing towards a string, it should be a string. If it's pointing towards, I don't know, Hakim, it should be Hakim. You get it? That's the kind of thinking that I want you to think. The same type doesn't really matter. Our point is clear. This is the theoretical part. We get into the practical part in a minute. This is all you need to know theoretically about a pointer. Now everything else is practice. Is the theory clear? I need more yeses, please. I can't really move on from here until I get a proper chunk of yeses. Otherwise, I'm not moving. Lovely. Now on to the interesting part. Let me share my screen real quick. You lot can see my screen. I reckon you can. All right, lovely. So how do you write a basic C++ program? What's the first statement that you need? Go on, I'm listening. What's the first statement that you need to write a C++ program? Preprocessor directive, that's very theoretical, but yes. Include IOStream. Do you know what IOStream stands for? IOStream is an input-output stream. It allows you to use the input-output from Puto. You have your camera on, by the way. It is a library. It is a standard library. It's a library that Björn Strostrup bestowed upon us, basically. And we need the int main. The int main is the entry point for our program so that our program knows where to start. It starts with int main. Using namespace C++, using namespace std, sorry, you can use it. I personally don't prefer using it because it's a namespace. Yeah, you can do it, but if you don't want to do it, you could do this, for example. Cout is in this is a standard library. What you could do is that you could do std, stick it to a colon in there. It's gonna work just fine. But that's very advanced. Just know that it's there. Just know that it's there, but that's a bit advanced. For now, here's a namespace std. Move on. Right. So how do you declare a pointer? Let's assume that I have an integer called Hakim, and I set it equal to 50. All right. If you want to create a string variable, you should include string. No, you don't really have to. If you want to use stuff like getLine, then you need string. If you don't, then no, because IOStream already includes all of the things that you need already. IOStream in these includes in the input stream and the output stream. It already includes the string for you, so you don't really need it here. String name equal to Taki Cout name, and it works just fine. Oh, vector, you need to include vector. For vector, you need to include vector. You need to come up here, include vector, and then you can use your vector as you like. You can use your vector. These things here are for templates. Either way, not the point. I want to create a pointer that points to the variable named Hakim. How do I do that? Now tell me. Come on. Snap, 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 snap. Come on. Snap, snap, you lot. Come on. How do I declare a pointer? Precisely. BTI is equal to and Hakim. Now, if I were to output PTR, have a look at this. It's magic. It's dark magic. See this? This is the memory address. This is the memory address for the this is the memory address where Hakim, the variable Hakim, was stored. Now, if you want to have a look at it, proper look at it, I can stick a debug here, and I can come up to debug, Windows, memory. Give me a memory. Give me a memory. There it is, memory 1. I can have a look at memory, and then I can put and Hakim in here. Have a look at this. This is basically the pointer, the memory itself. You see Hakim is stored in the memory here. Hakim is stored in the RAM. I want to see what's inside the RAM. Here it is. Now you can translate 50 to hexa. It'll translate to 32 because in here is the definitions. The content is in hexadecimal. So yeah, you got access to that. This is literally the memory. You can have it inside here. And this is the memory address. This thing here is stored in here. Have a look at this. Remember this? Yeah, remember this? Yeah. If I press F10 in here. Snap. Have a look at this. Isn't that the same? Yeah. Isn't this the same as this? Yes, it is. Because that's the functionality of pointers. Now, is this clear? This is how you do it in C++. So it is an address. It is an address. It's literally an address in hexadecimal. It is literally an address. It's a bunch of integers. So clear? I'll move on to a ubiquitous use for pointers. Now, one of the use case scenarios in pointers is arrays. Now, you might be thinking, how is an array? What's the connection between a pointer and an array? I'll show you. Let me just pull up my good old friend Paint in here. So you studied arrays, yeah? Yesterday, you did arrays, correct? Yes or no? Right. Can somebody tell me what an array is? All right, give me a definition of an array. Come on, snap. That's not waste time here. Come on. A bunch of data stored together. Precisely. Where is it stored? Where is it stored? Come on. Snap, lads. It's not stored in an address. What? It's not stored in an address. An address is an integer. How do you store a data in an integer? A memory, exactly. Now, how does it store it? Yes, it's stored randomly, but is it a memory block? Is the block next to each other, or are they different, or are they separated? How is it? Precisely, block next to each other. So if I was to draw an array, this would be an array right here. This would be an array. So if you take, for example, A, B, C, D, A, B, C, D, and I'll add an A here, an E here. So this is an array. Now, it is next to each other. Do you know what this means? This means that this is the start of a memory block. Let's assume that this memory block, the address of this memory block is 0x01. Now, what type is A, B, C, D, E? Is it a character? Is it not? Is it an int? Let's assume that, let's assume that it's a character. A character is 2 bytes, I think. Is it? Is it 2 bytes? I think it is 2 bytes. No, never mind. A character is 1 byte. Character 16 is 2 bytes. Yeah. So this is 1 byte. 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 So we've got 5 bytes. So what's the end of the block in here? What's it going to be? What's it going to be? It's next to each other, and each one is 1 byte. So what's it precisely is going to be 0x05. Is it though? This is 0x01, 0x02, 0x03, 0x04, 0x05 is going to be 0x06, because 0x01 plus 5 bytes is going to be 0x06. Do you get this? Do you get this formula? Now imagine, imagine that we have a pointer. Imagine that we have a pointer that points to, let me just remove this. Imagine we've got a pointer that points to the memory address 0x01. If I want to use this point to access this, or not to access, to point to the next one, what do we do? What do we do? We've got a pointer that points towards 0x01. We want to go to 0x02. What do we do? Precisely, we just add 1 to it. You just do pointer plus 1. And if I want to access this, if I want to get to this, what do I do? Pointer plus 2, precisely. If I want to access this, what do I do? Come on, you got it. Plus 3, precisely. What if I want to access this, what do I do? Plus 4, precisely. Now, remember this. Remember this. And by the way, if I want to access this, if I want to like stay in this, what do I do? What do I add? If I want to stay in the same place, what do I add? Precisely, it's PTR plus 0. Now remember this. Yeah, remember this. Put it in your head. Let's come back to C++. Now imagine that I have a character array of called, let's call it PTR. It has 5 characters in it, which are A, B, C, and D. If I want to access the first element, what do I do? If I want to see out the first element, what do I do? What do I do? Come on, chop chop. Precisely, PTR 0. If I want to see out the second element, what do I do? What's the number inside? 1. The third is 2. The fourth is 3. The fifth is 4. Sounds familiar? Huh? Sounds familiar? Doesn't this look a little familiar with you? Like, isn't it? Doesn't it ring a bell? Huh? What? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. What do I conclude? What do I conclude from this? Is there any conclusion that crosses your mind? Anything else? Anything? Just be bold. Come on. Try to find it. Close. Zhou Ming, you're close. You're close. I don't expect you to find it, to be honest, because it's a bit of a long shot. You need to have instinctive programming. You need to have computer science instinct to find this. But here it is. Here it is. What do you expect if I'm gonna say, for example, see out PTR and nothing? What do you expect? What do you expect to happen? What's the output that you are expecting? Say something, anything, just to make sure that you still with me. All displayed? No. Output everything? Bunch of random stuff? No. Check this out. Check this out. Remember this? Remember this? Remember this, you lot? Precisely the address of the first. Remember this? Huh? I use the same naming. I use the same name convention on purpose. Yes, it's going to give you the address of the first element. Shit. The output IB. Do you know why output A, B, C, D? Because it's a character. Let's change this to it really quick. Well, there you go. Because it's a character, it's gonna reverse everything. Because characters have a specific set of rules. We're gonna indulge later on. Check this out. Check this out. Do you know what this is? This is the first element, basically. This is the first element. This is the address of the first element. This is the address of a 1. And if I want to access the second one, I add 1. If I want to access the third one, I add 2. The fourth one, I add 3. The fifth one, I add 4. Do you get it? Do you have now an idea of how arrays are working? So let's assume that you've got let's assume that you've got a pointer. Sorry, let's assume that I've got an integer of called I don't know, cookie or whatever, 20. Let's assume that you've got a pointer S that points to cookie. Now I want to access cookie using S. What do? I put a C out and I use the asterisk in here with an S. Now this here means this is called a dereferencing. This is called dereferencing. Yeah, this is called dereferencing. It's basically saying, get me the value that's inside the element you're pointing to. Do you get it? Now, if I debug, this is going to give me a 20. Come on. Quit being a dickhead. There you go. That's a 20. Now, do you understand? Have you any questions thus far? Any questions? Any questions? Any questions? Are you sure? Are you sure you don't have any questions? Because that's weird. You either understood everything or nothing. It's like pointing back to the value from the address. Yes, precisely. Well, not pointing is getting the value. Getting the value of the address that you are pointing to using that particular pointer. This is exactly what I hate. Don't pretend to understand. Just because, listen, pointers, you're not supposed to get them from the first time. You're not supposed to do it. If you do it, then we should give you a professor's degree or something. Just let me just be clear. You're not supposed to get it. So if you have any questions, this is the time. Go on. What is it that you do not understand? What is it that you find in difficulties understanding? Because, you know, the whole C++, this is literally the hardest thing. Everything else is just, okay. We don't know what we don't understand. Yeah, that's fair. That's fair enough. At least you understand the theoretical concept. Because in order for you to understand the rest of pointers, you need to open up a compiler and work around, walk about and look about yourself. Do you understand the theoretical concepts? All right, cool. What's this asterisk for? Which one? This one is to declare that S is a pointer. This one is to dereference the pointer. Dereferencing is getting the value of this. So S is pointing to this variable. This means go to this variable. Open. Listen, do you remember the closet? Yeah. Do you remember the closet? Do you remember the closet? Basically saying, open up the door of the closet, get me the value inside. So is it like the address of an address in the is the value? No, no. So let me depict this really quick. So 20 is here, right? So it's like the key to a closet. Yes, JLSH, precisely, is the key to the closet. It means when we declare a pointer, we need to use S. If you want to declare a pointer, this is the type. Type plus asterisk, 100%. This is the only thing. And this is dereferencing. This is basically going, go to that address. Yeah, go to this address, open up the closet, open up the door, get me the value, output it. This is the same thing. This here, this line 9 means go to S, get the address, go to it in memory, open it up, get me the value, put it into cout, output it. Basically this. That's what it basically means. Got it? Array is like a container. It is a container. It is a container of a contiguous block of memory. It has a starting address and a pointer that points to the first memory address. That's what it is. Characters, however, are a little different because characters are being read until the, I don't know if Daniel told you this before, but there is a flag called the stop flag, which is this one. What can I store inside it? Anything? Yeah, you can just about anything, to be honest. Just about anything. You can store integers. You can store floats. You can store floats or anything. The only drawback is that they all have to be using the same. They all elements need to be the same type. They all need to be the same type of the same type. You can't really have different types inside for a particular reason, which I just explained. Now, if you've been listening and if you're little working with me, you'll be able to figure it out. Because the size needs to be the same. Because the pointer, how the pointer is accessing different memories is just by adding one, by going to the next memory. So if this is a float, let's say for example, this is a float of 16 bytes, and this is an integer of 8 bytes. Yeah, it's going to be a little bit different navigating, because if you add +1 here, it needs to move 16 bytes, but here it needs to move 8 bytes. So it's kind of difficult. So no, they all need to be of the same type. That's literally about pointers. The rest is you need to practice. That's just about it, honestly. Pointer arithmetic. I forgot something. Pointer arithmetic. Well, pointer arithmetic is a little different. Let me just summarize it in here. So if you have a pointer, if you have a type, and in C++, each type has a particular size. Yeah. So if you have a type, PTR, let's say, for example, +x. Let's say +x. So this here is equals to the memory address that you're starting with plus x times the size of type. What this means is the following. Now, imagine that you've got an integer, a pointer integer PTR that is equal to, I don't know, say x. Now, x is an integer. Now, let's assume that x is stored inside of the memory address of 0x003. Let's say 3, for example. Now, PTR +1 is not 0x004. No. So, depict this. An integer is 8 bytes long. Yeah, an integer is 8 bytes long. So in order for the x to be held, x is held within 8 bytes. 1, 2, 3, 4, 5, 6, 7, and 8. 0x03 is not this in here. 0x03 is in here. So where is 0x04? Remember, this is all x. This is x in memory. This is x. This is just one variable, x. Where is 0x04? If this here is 0.3, where is 0x04? Any idea? Is it this one? Precisely. This here is 0x04. So you didn't really move. You're still within x. I want to move to the next memory address. So what do I need to add? I need to add 8 bytes in order for me to skip x, in order for me to go through x and be here. Now 8 plus 3, that's 11. 11 is b, so 0x0b. So when you add 1, what you're essentially adding is, if you add 2, for example, you're adding 2 times 8 if it's an integer. If it's a float, is 2 times 16. That's why I use the size of the type, whichever one it is. So depict this, for example. Here's an x, which is equal to 50. It doesn't really matter. I'm going to have 2 pointers. Sorry, I'm going to have 2 pointers. X is equal, let's say, PTR1 is equal to address of x. Now check this out. See out PTR1 ++. And see out PTR and an end line at the end, because I need to Yes, precisely. But we didn't use an integer. We used a character. A character is 1 byte long. It didn't add 1 because of operation precedency. I added 1 to it and moved on. Now check this out. Now check this out. An integer is actually 4 bytes long, or is it 8 bytes long? C++ integer size. Yeah, sorry. An integer is 4 bytes long. A double is 8 bytes, yeah? Yeah, a double is 8 size long. 8 bytes. Sorry about that. An integer is 4 bytes long. So it's basically going to add 4, that's 7. So take a look at this. So PTR1 is this. It's stored in 0x102AD8F7D4. If you add 1 to it, it's going to add 4 bytes because an integer is 4 bytes long, etc., etc., etc. For your question, Wei Yi, we used in the previous example, it was a character, and a character is 1 byte long. So if you add 1, you're adding 1 byte. If you add 2, you're adding 2 bytes. If you add 3, you're adding 3 bytes. But in here, because it's an integer, and an integer is 4 bytes long, so if you're adding 1, you're adding 4 bytes. If you're adding 2, you're adding 8 bytes. If you're adding 3, you're adding 12 bytes, etc., etc., etc. So if you say, for example, a plus 3, the difference is going to be 12. I selected previously. So, yeah. Plus equals. Forgot the equals. Did you learn about this yesterday? I don't think you did. Yep. There you go. That's 12 bytes. That's literally 12 bytes. You can subtract and everything. So this is basically the point of arithmetic. Understood? Do you have any questions? Any issues with it? Any questions? Alrighty then, we're gonna get into files. Now, file processing is a bit okay. It's not as difficult as pointers. Trust me, every other concept is simpler than files. Yeah, what's up?
A guy named Chiming asked why the answer is show address.
Why the answer show address? I'll show you why. Look at that. We're outputting the PTR, the pointer itself. The pointer itself is that we're outputting. That's why it's an address. Now, if I stick this in here, check this out. That's going to be different. The second one is going to be gibberish. The first one is going to be 50. Yeah, check this out. It's going to be negative. I don't know what this is. Because it's a memory address that's not ours, by the way. We're accessing a memory address that's not ours. We don't know what's 3 blocks away from X. We don't know what it is. Imagine memory as a neighborhood. Yeah, we know what's in X. We know what's in this address, but we don't know the family that lives 3 blocks away. We don't know that. Get it? So yeah. Well, the meaning of finding the address. You mean why is it useful to know the address, or what is it used for? One of the use cases is arrays, like I just explained. If you've got an array of 50, I think I'll have to get into this. I'm sorry, Hakim. I think I'll have to get into this. All right. To answer your question, Jun Wen. All right. So in C++, we've got this idea. We've got 2 memory allocations. We've got 2 types. We've got the stack. We've got the stack, and thank you, Hakim. And we've got the heap. You really can't talk about pointers without talking about the heap, because literally that's the whole point of a pointer. So the stack is the block of memory that the operating system gives to us upon compilation. So when we hit compile, the operating system is going to calculate our needs and allocate it to us in here. Literally, it gives us this allocation. It gives us this. It tells us, look, this is the memory block that you need. This is the memory block that you have. I'm not going to give you any more. I don't care what you do. I don't care. This is the memory block that you get. This is the stack. It's not resizable. I can't add to it. I can't take away from it. It's ours. It's calculated. This is what you need. Now the heap is something else. You see, when you hit compile, and the operating system calculates this memory block, gives it to us. Now, when we are executing the program needs extra memory. Now, it can't come to this place and gives us, well, just allow us to take one more. No, you can't do that. Why you can't do that? Because this memory block that's literally next to you, it could be used by another program. It could be used, for example, I have Visual Studios open and I've got Zoom open. I don't know. I might stumble upon a memory address that's used by Zoom, and then I'll mess up the whole computer. So it doesn't give this to us. So what we do when we are executing the program is being executed. It's compiled, the stack has been allocated and everything. Now it's in the execution phase. You know, when it's in the execution phase, when it needs extra memory, it talks to the operating system. Our program talks to the operating system. Yo, boy, we need some extra memory. Give us some. Now, the operating system is going to go to another completely separate block, another town, another city in the memory, and it's going to look for a block. For example, the program is going to tell the operating system, I'm going to need 50 extra bytes. I need 50 bytes. 50 extra bytes, give it to me. The operating system is going to look into the other city, is going to look for a 50 bytes of memory that's contiguous. It's going to look for it, and it's going to return it back to us. Now, how does it return it back? Can somebody guess what's going to give us? Anything. What's it going to give us? Cache? No, that's too much. Exactly, Cham is going to give us the address of the new block. It's going to give us this. It's going to give us this. And we know it's 50 bytes long. So we can access literally everyone. Every single one. Because we know how big it is, and we know the start. And we know how it is separated. For example, if it's an int, each block is going to be 4 bytes. If it's a double, each block is going to be 8 bytes. So using this, we can literally access everything else. Do you get it? Now, if we need extra memory while we are running the program, if we need extra memory, what we do is that we declare a pointer, we give it a name, and we set it equal to, and we set it new int. Now, what this means is, this little thing in here, what this means is that when you hit compile, let's give it an array, so just so that I would have a little more room to work with. All right, in here. So we've got 2 arrays. Yeah, so we've got 2 arrays. Let's pull this up. A is going to be allocated when we hit compile. When we hit compile, when we hit F5, A is going to be allocated. However, P, this block of memory, that's 10 times 4, that's 40 blocks. That's 40 bytes. These 40 bytes are not going to be allocated when we hit F5. It's going to be allocated when the execution reaches line 7. When the execution reaches line 7, then and only then will the memory be allocated. And because this is going to return a memory address, We need to store it inside what? What do we need to store it inside? Come on, give me the answer. A pointer. That's why we need pointers. That's why we need pointers, because we need to somehow get the data, get the memory address that's going to be allocated to us. That's one use for it. And trust me, this, you're going to be using it quite a lot. You get it? Whoever asked the question, what is used for? June, when? June, you get it? Good. Now, let's talk about files. How do we know that we need extra memory? You're the programmer, you tell it to. All right. Let me give you an example. Let me give you a use case. Yesterday, when you studied arrays, one of the things that you do, one of the things that should be is the size of the array needs to be a constant. It can't be a variable. So if I have, for example, size equal to 10, if I want to declare an array with size, I can't do this because the size needs to be constant, because this is going to be allocated in the stack, and the stack, the size of it is predefined. So if you give me a variable size, I'm not going to be able to allocate a particular set of in the memory. I can't do that. So if I want to allocate a flexible array, what I need to do is I need to allocate it in the heap. Rog. Copy approved, Hakim. Check this out. Now I can allocate it in the heap, because this is a dynamic array, because we allocate it using a variable. We can later reallocate it. We can later literally delete the whole thing. We can literally later delete the whole thing and allocate it again. We can play around however we like, plus 50 for all I care. We've got flexibility. We're not static. We don't have constraints of memory. We can add, remove, however much we like, as long as we don't go beyond the available memory. So if you've got 16 gigabytes, let me just give you really quick. The amount of memory, for example, that I can use, for example, in my RAM, in my memory here. Yeah, so 10 gigs is used, 5.1 gigabytes available. I can go allocate all of 5.1. That's going to crash my computer. I don't want to do that. Neither the compiler is going to let me. So yeah, you got that. So you lot, let's talk a bit about files before we actually get into get the break. Thanks, Hakim. We're going to talk a little bit about files, then get into the break. 9:10, we're going to have a break. Yeah, 10 past 9. All right, so in order for us to work with the files, we need to include the files library, which is include fstream, file stream. There are 3 types of files. Let me actually pull up the slides for this one, because it might help you visualize a little bit more. Let's go. Can you lot see? All right. Can you lot see the files? Can you sort the slides? Sorry, what files? Lovely. So file handling. Right. So we've got a quick look into the process. What we do in, you know what? This is just not just C++. This is pretty much every other programming language. Whenever you want to perform file handling, you open up file or create it. You write the file, you write into the file, or you read from the file, or you perform whatever you like. Just do your thing with the file and then close it. Don't forget to close it. You have to close it. You got to close it. So step 1, opening up the file. There are various ways of doing it. There's the open function, or you can use the constructor. You don't know what a constructor is because that's very object-oriented programming. But first thing that you need to do is you need to declare a file object and use the open function to open it up, or you can just use the brackets. You can stick a brackets in here. Now it takes two arguments. Well, minimum one, maximum of two. It takes the name of the file and it takes the how you want to use the file. So for example, these are the modes that you open it up with. And for example, in opens the file to read, out to write into the file. Binary is to open it up in binary mode. App is append, to append into the file from down. ATE ups the file and moves the control to the end of the file. The control is the file pointer. I'll explain what this is in a minute. Trunk is to remove the data in the existing file. No create, open the files only if it already exists. So if it doesn't exist, don't use it. And the way that these are declared is iOS. Let's say, for example, that you want to use is it in the slides? No. Let's say, for example, that you want to use in, out, and binary together. What you would do is that you would have an iOS out and then the bitwise or operator, not the logical end to not this. I can't. You wouldn't have not this. No, the bitwise, which is this one right here. Come on. You would have them all put together. No replace, open the file only if it does not already exist. So just basically just to make sure that you don't replace a file that you already have. Oh, sorry, make sure that you don't create a file that overrides the one that you already have. That's a better way to phrase it. This is a sample program that we use. We're gonna use it plenty. An F stream. We need to explain what F stream is. Right. So back here, we've got three ways of doing it. There are three ways of doing it, really. You've got an if stream, off stream, and F stream. F stream is input. This is input file stream, and input is relative to your program. So if you're reading something from a file, that's considered an input to your program. So this is reading from a file. Output is when you write into a file. F stream is both, but you can specify the mode using the flags. What are the flags? These ones right here. Oh, thanks. These ones right here. So to declare a flag, you can use iOS or you can use F stream, whichever one you prefer. They both do the same thing. Now, let's say, for example, if you want to open up a file using F stream, you want to open it up to read and write. What you would do is that you would basically get your file, F stream, call it something, files, give it a name, user.txt. Now I want to open it up to write from it. To write from it, which is output. So out. I want to also use it to read from it. So I put the bitwise or operator in. I want to also append to it. F stream append. Oops. Here, I opened up a file called user.txt to write, read, and append. If I want to, so the writing style is going to be append. It's not going to be from up top. One other way of doing it is that we can take this off here, use files, put dot, get an open, and put my stuff here. It's literally the same. If you know a little bit of object-oriented programming, you know that this is a constructor. This is basically opening the file using a constructor, and this is opening the file using the open method inside of the FStream class. Because essentially, this is a class, by the way. This is a class called Basic FStream. Yeah, this is a class. If you know a little bit of, object-oriented, you know this is the constructor. It takes a file name. The mode is the mode. All right, got it? I suppose you did. Do you have any questions about this? thus far, opening up a file. Any questions about opening up a file? Literally, just opening up a file. Any questions? I'm listening before we actually take the break. It's a little weird. No questions. Gets me stressed out, not gonna lie. All right, then. I'll see you lot in 10 minutes. We're having a quick break. Just drink some water. Don't forget. I used up most of my energy. I need some oranges over some vitamin C. All right, so I'll see you back at 9:20. All right. Cheers. You lot are okay if I put some music on? DSA tutorials, what do you mean? Data structures and algorithms. Yeah, there are. There's a ton. There's a ton. So I recommend the channel. You can check out the channel. Data structures, honestly, there isn't much in data structures. You can just do it yourself, to be honest. If you're coding off of C++ and pointers, you can do it yourself. It's not complicated at all. Data structures, people are scared of data structures because they don't quite understand the semantics and they don't fathom the abstract concepts of a particular language, so that they can make their own data structures. To be honest, it's not that difficult at all. If you take linked lists or hash maps or any of the sort. All right, I'll see you in 10 minutes. No copyright sounds. Let's go.
Nikmati Italian BMT di Subway. Kini lebih padu dengan Italian BMT Double Cheese dan BMT Plus baharu.
Premium lets you zone in on what you love without audio interruptions, whether winding down or turning the volume way up. Take control of your mood with non-stop ad-free music listening to keep the good vibes going. Ready to dive back into premium? Tap the banner to learn more.
Hello, people. 1 more minute. Wait, there's someone called Naomi. That's a nice name. Naomi. Are you not here? You back? Let's go. Files, make the project, and we roll. Pog. Right, shall we start? Can I get a yes in the chat if everyone is here? Aye, let's go. I don't see a lot of yeses. I don't reckon people are back yet. 35 participants. That's a lot less than yesterday. Fair enough, fair enough. Those have got the guts to stick around for the second day. Those are the ones who will become good developers. Honestly, that's something that you should take in your whole computer science journey. It's not about when you begin, it's all about when you finish and how you start, when you basically continue, stay consistent. Who was here yesterday? Who was here yesterday? Say hello. Pog. Pog to those who stand. Pog. F. Respect you lot. Respect. F in the chat for those who were yesterday and today. Alright, let's start. Let's go back. You lot ready for this? I'm ready. Let's go. Share my second screen, which is this one. Let's roll, people. Let me just pull up the chat so that I can see your questions. Here is your chat. Here are the participants. Don't really need this one much. I need the chat in here. Good. Check what's up. Rog. Yeah, I could do that. Yes, I'll do that. I will do that. Can you hear the music? No. I bet. Just a second. I'll share my computer audio as well. Share sound. There you go. You'll be able to hear it now. Right? Should I turn it down a little more? Or is it good? Turn it down, turn it up a bit. Rog, back into it then. Let's go. A bit of lo-fi in the background. Why not? All right. So we learned how to open up a file. Now, how on earth do we close it? Because listen, whenever you open a file, you need to close it. That's literally the first thing you do. Whenever you open a file, directly close it. And then you can do the stuff in between. How do you close it? You basically use this same thing here. You can call it X, by the way. You can call it Y. You can call it Hakim. You can call it Cookie. You can call it a cookie. Whatever you like. You can call it. You know what? Let's call it Nasi Lemak, because why not? Yeah, let's call it Nasi Lemak. Yeah, call it Nasi Lemak. You call it Nasi Lemak. You do Nasi Lemak.open. Put the arguments in there. Nasi Lemak.close. Congratulations, you opened up a file and you closed it. Now, it's good practice that whenever you open it, you close it, and then you come here, do whatever you like with the file. Now, what we're going to do is read. There are multiple ways to read from a file. Let's say for user.txt, I've got a bunch of users in here with semicolons. What you could do is check this out. I need a string so that whenever I read things from a file, I put them in a string. Check this out. Nasi Lemak name. Remember, this is an input. So you use these, an input from a file to the program. So you use these. Let's just see out name. Check this out, ladies and gentlemen. It's nothing. Come on. What did user use in the slides? Because I don't want to go off slides. Creation, like clause. Yeah, read that. Oh shit, that's an input. That's an output. What am I doing? What am I doing? What am I doing, bro? There you go. Check this out. Remember this user.txt, yeah? You ain't got nothing more. Let me close it. Just close this really quick. Perfect. Check this out. What? Come on, bro. If it's a stupid mistake that I'm using, I swear to God, I'm gonna be super pissed. Thank you. Still nothing in there. Am I opening the right? Oh, of course. Yeah, I told you it's a stupid mistake. Check this out. Check this out. What's the name of the text? What's the name of the text file in here? Uses. And I used user. Yeah, I told you. I told you it's gonna be a stupid mistake, and then I'm gonna be super pissed. I hate these mistakes, honestly. Because they make you re-question your entire ability to write in C++. Check this out. Check this out. I wrote into a file. It literally made me question if I'm doing this correctly. Well, the mistake is literally an S. It's a little funny. It's a little funny. Yeah, funny highlights with Taki. Let's go. Why not? Happens to the best of us. You need to understand that. So this is if you want to write into a file, you basically write that. So check this out. Because I have append, if I write it, if I basically read it again, put it again, it's going to put it in the appending, basically adding to the back, adding to the end of the file. Now, if you want to have a new line after this, what you need to do, because C++ is not gonna magically know that you want an end of file there. I'll explain why in a bit. But if you want to add a new line in there, just add a new line here or use the end line. It literally works as well. So let me run it a couple times. I run it once, run it twice, run it 3 times. Check this out. Check this out. Run it once, twice, 3 times. Now I don't have an end line in here because before I run it 3 times, I didn't have a new line. So you've got that. But now that I added a new line, look at this. There's an empty line in there. So if I run it for the 5th time, or the 4th rather, check this out. The 5th is going to be filled out, and the 6th is going to be a new line. Yeah. Sometimes while reading from a file, these new lines could be a little bit problematic. So it's good practice that what you do is that you don't add a new line at the end, but rather you add it at the start, at the beginning. So this is the end of the file. So what you're going to do is you're going to add a new line. So it's going to come here and then output Taki to it. This is what you're going to have. Now check this out. If I do this one more time, I'm going to have a Taki in the 7th, but I'm not going to have an 8th line. I'm not going to have an additional 8th line. Check this out. I'm not going to have an 8th line. I'm just going to have the 7th one. Now, what happens if I remove app? What do you think is going to happen? Let's use a different thing. What do you think is going to happen? There is 1, 2, 3, 4, 5, 6, 7 lines, 8 Takis. Let's check this out. Thank you. It's in the beginning. And the extra line is gone. It basically, it was overridden. See this? See this? See the difference? Do you see the difference between the two? It basically removed these two another different thing. Got it? That's why you use append to basically avoid overwriting data that's already in the file. Now, if you wanna read from a file, you'd use a string name, this name, and then you see out the name. Check this out. First, Taki. Taki. Now, if you want to read more, you add more. There are more sophisticated ways. Taki, because everything is Taki, for God's sake. Let's put this, for example, 1, 2, 3, 4, 5. Check this out. So I'm going to read the first one, and then I'm going to output it. End line. Just a second. I'll re-explain it. Yeah, I'll re-explain it. Just a second in it. It's a little bit complicated than that too. And I can't really explain it in detail because it needs object-oriented programming and it's a bit complicated. So I'll try to simplify it. Just a second. Just give me a second here. So what's going to happen is this. This Nasilamak is going to read 1. This here is going to read 2. This one here, this here is going to read 3. And this here is going to read 4. Check this out. 1, 2, 3, 4. That's what happens. Now, if I add 1 more to it, then I read 5. There you go. And if I remove this end line here, I won't have an end line at the end. I won't have an end line at the end. Now, for your question, fstream is this whole thing is called an object. It's called instantiating an object of type fstream. But we really don't want to call it that because you need to have some kind of an understanding of object-oriented programming. So just understanding that in order for you to get anything, in order for you to understand, in order for you to open up a file, you need to use one of these, either an ifstream, an offstream, or an fstream. An ifstream is to import a file, basically reading from a file. Offstream is to write into a file. And fstream is for both, if you want to use any, and then specify in here which type. So if say, for example, that I want to read from a file, if I say ifstream in here, if I say ifstream, if I try to write into a file like we did earlier, it's not going to like it. It's going to tell me an error. No, you can't do that because it's an ifstream. You're supposed to only read from it. You're not supposed to write into it. That's wrong. You get it? So if I say, for example, off stream, everything's going to highlight in red because it is supposed to write into a file, not to read into it. F stream is for both. If I don't specify, it's going to like them both. But in order for me to, the issue that we had earlier, overriding data, what you need to do is make sure to add append into it in here, just to make sure that one of the data that you're adding is being appended, is being added to the bottom of it, not to the top of it, and then you override all the data, and then you're gonna have problems and data loss and everything. So we don't want to avoid that. We do want to avoid that. Yeah, you really don't need it because it's an F stream. You really don't need it. Yeah, thank you, Hakim, for the W3 Schools. W3 Schools is an absolute legend. You can check out Geeks for Geeks as well. Geeks for Geeks is amazing. So that's one way of reading data, but we need some kind of a more sophisticated way to read data from a file. For example, the issue we had earlier in here, this in here. The reason why this is structured this way, I'll explain it when we start the project. But the way this is structured is we want to get each one of these separately. Yeah. What's the pattern that we're using? Each data is separated by a semicolon. So we want to keep reading data until we reach this semicolon. This is what we call, thank you, Cham, a delimiter. Now, there is a function, and in order to use it, you need to include string. There is a function called getLine. what we need to do is we need to have a string so that we can store the data that's being read from the file, store it in there so we can use it. There's something called getLine, and getLine, what it takes a stream. It takes the file object that you used to open the file so that we can read from it, and then it takes the string that you use to store data in, and then you get the delimiter. The delimiter could be any character. It could be A. So if I say, for example, A, it's going to read T and stops. And then it's going to read A, K, I, semicolon, T, and then stops. Because the delimiter is A. The delimiter is where it stops the reading. So if I say, for example, semicolon, it's going to read the file until it finds a semicolon. And then it stops. It doesn't continue. Yeah, so for example, if I see out in here, starts from A and stops before A, it doesn't really matter. So if I have an A in here, it's gonna read until it finds an A, and then read from it until it finds the next A, and then read from it until it finds the next A, etc., etc., etc. Now, because it's a semicolon, it's gonna start reading. Let's remove this. Is going to start reading T. Is T a semicolon? No. Continue. Is A a semicolon? No. Is K a semicolon? No. Is A a semicolon? No. Is a semicolon a semicolon? Right. So stop here. Stop here, rather. And then it's going to continue reading from here. And then it's going to continue reading from here. And then it's going to continue reading from here. Sorry. From here. And then 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 from here. Get it? That's basically how it's going to read everything. So if I see out read line here real quick. If I see out read line in here really quick, it's going to output the first Taki. Come on. Just put it in here. I'm using C++ 20 or 14, is it? There you go. It's going to output the first Taki in here. And then if I do 3 get lines, and then output what it's going to read, what it's going to read. 1, 2, 3. It's going to output admin. Check this out. There you go. That's the admin. That's basically the function of a delimiter. That's the function of a delimiter. Get it? And there's a question that asked me earlier. Apparently in the new C++, you have to specify what you want to do. In the old C++, you didn't really have to, but in the new C++, apparently you have to. I'm not sure. There's someone who, yeah, Lester, you asked me, there's no need for in and out, so just app in there. Apparently you have to. Just be safe and use them. Just to make sure that you don't override any data that you don't want to use. So yeah, that's getLine. That's really everything about files. Everything else. Oh yeah, we need something. We need to talk about something. Alright. So the way that files are being handled in C++, there is a file pointer, not the pointer that you know of. No. Another pointer, something that is used to track down the current character that's being read. So the pointer firstly starts at the top left. That's where it starts. And it starts reading character by character, character by character, character by character. And by the way, a new line is read as this character. A new line, whenever it finds a new line, it's this one. Got it? So Taki is read as new line TAKI2. Let me give you an example. I read 5 times. Yeah. I read 5 times. I'm going to output 5. Now, usually, because I didn't do an end line in here, the read line, the 5 and the read line should be together. But because it's reading a new line from here, they're going to be stacked together. That's going to be not stacked together, stacked on top of each other. Check this out. Now, under normal circumstances, if you have 2 C outs in here, it's going to be 510. It's not supposed to do it in here, is it? Yeah. Taki 2 is supposed, the output is supposed to be like this. The output is supposed to be like this. 5 and then Taki 2. This is the output that I'm expecting because I didn't specify a new line in here. But the output, however, was this. This implies that Taki 2 is being read with a new line before it, and the new line comes from here. If you want to strip it away, there are ways to do it, which I will show you how to do it in the project, not right here in the in and out. So we've got that out of the way. That's just about it. Now, any questions before I start doing the sign in and sign out? Sign in, the login sign up function. Any questions? Come on. Take your time. All right, then. Let's go for the project. What we want to do in the project is very, very simple. What we want to do is the following. You want to have a login feature, a sign up feature. Now, how do we do them? Usually we've got a database that we can store data in, but right now we don't have a database. So our files are our database. So what do we need to do? What's the first thing that we need to do? If the files are our database, how do we handle the files? How do we do them? How do we do it? Well, let me help you out. Firstly, we open up a file. We open the file, and then we prompt the user what it wants, what they want to do. They've got two choices. Choice 1 is they choose login. Choice 2 is they choose to sign up. Now, login means go into the user's file, find the username and password, find the username and pass, prompt back with the result. Now, sign up means go into the user's file, append. We want to append new user. Now, this is why the structure of the file comes in. This is where you have to be smart about it. Now, here it is. We want to basically get the username and the password separately. Yeah, we want to get the username and the password separately. Well, what we can do is have the username in one line and the password in the second line, and then username and password, username, password. But to pick this, if I want to get the third username, I have to get the 6, divide it by 2, and then move 1, 2, 3, 4, and then move 3 plus 1. That's too much. That's too much operating. That's too much. We want to store it in a way that we can just get them instantly. The way I usually do this is I use a delimiter. I use a clear delimiter between the first and the second one. So I usually use username, password, stop. So this is a user, one line. Yeah. This is second user, one line. Third user, one line. And I use the get line with the delimiter of I can't speak English anymore. The semicolon. I use the semicolon as a delimiter. Now. How do we do this? Well, first we create the file, which has been created, already created before, and we start writing code. So the first thing we want to do is I want to prompt the user, please choose what you want to do, right? So we output the menu, which is 1, login, Remove this. And line. Just do this so that it's clear. Or 2, sign up. Now we want to prompt the user for input. How do you input? Precisely. You import with CIN, but in order for you to import, you need a variable to store the input in. You don't really need a string in here because look, they're going to be using 1 or 2, so it's an int choice. So CIN choice, because what they're going to do is basically choose 1 or 2. So if they choose 1 means log in, if they choose 2 means sign up. Let me just tidy up the output a bit. Yeah, you can code along if you like. So you've got that. You've got that out of the way. So in order for you to determine what code is ran, what do you use? I want the user, if they choose login, I want to perform a login. If they choose sign up, I want to sign up to be performed. I can use an if statement. Is there any other alternative? Case. Exactly. Switch is not called the case. It's called a switch. Yeah, you can use if statements if you like. It's just going to be if, and then else if, and then else, which I don't like the structure of it. Do you mind sharing the source code, Hakeem? We sharing the source code or we letting them focus? I'd honestly say don't. Let's see if Hakeem is kind enough. All right, we'll share it. Yeah, code along for now. So we've got 2 cases in here, don't we? We've got the case 1, the break. And we've got case 2, and then the break. The case 1 is login. Case 2 is sign up. But we have an issue. What if they enter 3? What do? We want the user to still be able to input. We want the user basically to input until they get it right. Until it's either 1 or 2. How do we do that? Do while loop? I don't prefer do while loop, to be honest. Yeah, but the default, you see, if you put a default in here, for example, wrong input, buddy, please try again. Hey, try catch. What? Not an exception. We're not dealing with exceptions here, buddy. You don't use try catch. Let's say if you see 3, for example, you're just going to tell me wrong input, buddy, please try again. We want the user to be prompted again. Yes, we can use a do while loop. Very much, yes. We can do this. A do while. While what? While choice is not equal to 1. Or choice is not equal to 2. Yeah, bruh. What can I tell you? I'm not rich enough to get me a Spotify premium. There you go. Alright. So if choice is not equal to 1 and choice is not equal to user to enter again, check this out. So if it's 3, thank you. Hold up. Easy there. Easy. Check this out. I need the input here. It's not an end, it's the input. So if it's 3, it's going to tell me try again. If it's 1, it's going to try again either way. Yes, it should be an end in here. You're very much correct. 3, try again. 1, over. So if it's not equal to 1, and it's not equal to 2, so if both of these are false or false is false. If it's equal to 1, this is just basically going to turn into false. So this whole thing is going to turn into false, and then it's going to continue. There's no need to evaluate this one in AND operation. But if choice is not equal to 1, if this is true and this is true, it's going to play this again, etc., etc. So now we want to perform a login. Now, how do we do a login? Well, first, in the cases, if you have more than one statement, you have to put the brackets. What do you want to do? So we want to open up the file. Yeah, so we want to open up the file. Let's call it users.txt is our file now. Users.txt. We want to read from it. So it's an input. We want to read from the file. Or if you want for fun, you can declare them all. It's not good practice, but either way, let's just do it. String, thank you. Good practice is to, when you open it, close it so that you don't forget. All right. So now what we want to do? Yeah, we want to get username. We want to get password. And then we want to find username and password combination. All right, let's do that. So let's get the username. See out. Enter. Well, let's just put an end line in here. There's going to be an end line out of the way. So enter the username. And we need a string to store the username, and a string to store the password. So CIN username. We've got the username. Now let's get the password. Now that we've got both the usernames and the passwords, now what we're going to do, we want to keep reading from the file. We want to keep reading from the file until we find the username and the password. If we can't, then we basically tell them that the username doesn't exist or the username password combination is wrong. Basically that. So I'm going to use the get line, and we need another string to store the data that we read from the file. Get line, as I explained earlier, you get the users, the read line, and the delimiter that I used, which is this thing here. So as long as I'm getting lines, as long as I'm reading, continue reading. One other way of doing it is while not users.eof, and eof is end of file. So as long as it's not the end of the, keep doing what I'm doing. But I don't like to use this very much, as sometimes I've got some extra space in here which messes up the whole algorithm, and sometimes I've got data, I've got arrays, and when you have the array inside, and especially if it's heap allocated, it's not going to give you a clear-cut error. It's going to give you an exception, and then you have to find the error yourself. So I wouldn't really recommend that. That's why I don't like using the end of file. I like to use as long as you're reading the line, and when you're reading the line, there is data. And usually in real world program, you would check for this data if it's empty. You would do empty. If it's not empty, you put this inside of inside of an if statement, and then if it's not empty, you do things with it. But this is a demo program, so we're not going to get into that. So we've got the read line in here. Yeah? So what this is going to read, firstly, it's going to read a username. And then we want to check for the username. So if read line, if the first thing that it's going to read is equals to the username that we have, if it is equal, then get the line and read the password. So this is going to read username. This is going to read password. Got it? So if it is equal, read the password. If the read line now, read line here is going to hold the username. Read line here is going to hold the password. So if the read line is equals to put the password we have, tell them logged in, you may continue doing whatever you like. You can redirect them, you can prompt them to go to a particular to a particular code, to a particular block of code after the while if you like, or anything of the sort. So that's if they are found. But what if it's not found? Yeah, what if it's not? So if you want to, if I need to know if the password of the username is found or not, what I can do is I can use a user found flag, set it equal to false, and password wrong flag. Password wrong, which is equal to false. So if they found the username, what I can do is found, sorry, what did I call it? What did I call it? Where it is? Where is it? Ah, there it is. User found. If the username has been found, set the user found to true, which basically means, yes, I found your user. And then if the password is matching, set the password wrong. Sorry, set the password. Just call it password. Set the password equal to true, which basically means that both the username and the password are true. Now, why did I do that? Is because I want to check after the while loop. I want to check if the user is found. If the user found is equal to false, this is just one way of doing it. If you want to do it, you can do not user found. You can prompt that user does not exist. Please sign up. Just put an end line in there. And same thing goes for password. So if not the password, say for example, user exists, the password is wrong, please try again. Get it? Now let's try this. Let's try this with something that already exists. Let's choose login, enter the username. We know, for example, that username. Yeah, I'm gonna have to run it a bit late to that. I can't finish the rest in 2 minutes, sorry. So let's use, for example, username. Username, we already know that username exists. But the password is password. Let's just use something else. Let's say, for example, 123. User exists, but the password is wrong. Please try again. If I choose a username that doesn't exist, for example, this, and doesn't really matter what the password is, user does not exist, please sign up. Oh yeah, we want this to only output if the user is found. How do we do that? You add an end here and make sure that the user exists and user found. So if the user exists, output it. If the user doesn't exist, then just don't output it. One other way of doing it as well is to take this in here, basically. But this is just this. No, actually, no. Never mind. This is if the user does not exist. So we want to check if the user exists. So this is going to basically do if the password is wrong. So the password is still false. It didn't enter here. It didn't get here. The password is still here. If it didn't get here, which means that this if statement was never ran, it never got inside. So basically the password is still false. And just the fact that we entered this block, it means that the user has been found, which basically means this is true, which basically means true. And this is false. Not false is true. True and true is going to evaluate in here. Check this out. Username, whatever, password, whatever. User does not exist, please sign up. Now, if we use a username that exists and the password is right, logged in, you may continue doing whatever you like. So you're basically logged in. Now, how do we do the sign up? The sign up is relatively straightforward. We want to open the file. We want to open the file, get input, append to file. Or rather, before appending to the file, this is optional. We can check for usernames if they already exist or not. We can check for the username if it already exists or not. So let's get the input. It's just going to be the same in here. So I'm just going to cut and paste. Username, password, read line. I'm going to use this to read the line to check if the username. So let's do this. I'm just going to copy and paste this so that we don't have to read it again. Now the logic inside is going to change just a bit. This is going to change in here. So if the username already exists, what we want to do is that we want to break out of the loop. Well, first we want to output that the user name already exists, and then we want to break out of the loop. We want to just stop the loop. Don't even continue. And we want to set the user found to be true, so that we can check. Here if the user is not found. If the user is not found, then we can sign a person here. If it is found, then this is not going to, if it is found, this is true, true, not true is false, not false is not going to get evaluated. It's just going to skip the code. So we've got that out of the way. We don't really need to check for the password because it's there anyways. So how do you output this? Well, first you need to respect the structure in here. So what we need to do is that, just as I showed you earlier, you get the user. And well, first you output the username. And then you output a semicolon. And then you output the password. Semicolon. And you stop. Frankly, because there is no new line in here, if this is going to get appended, it's going to get appended here. We don't want that. We want to append it in the new line. So what you need to do, output a new line in here. Do you understand? Do you get it? Do you have any questions about this? Let's check this out. I want to sign up. Let's use a username that already exists. For example, username, pass. The username already exists. Come on, music. Don't do this to me. Now, let's use something that doesn't already exist. Does Taki already exist? No, Taki doesn't exist. Let's use username 3, for example. Username 3 was in. Isn't that weird? Username 3 was accepted. Oh, yes. Yeah. Sure. At the end, we need to make sure that we're reading the username, not the password. The way you do that is by making sure that you read the line at the end so that you move to the next one. You don't read every line unnecessarily. Sign up, username 3, username 2, password, whatever. It's a little weird, man. Why is it accepting it? It's not even reading from it. It's weird. Oh, I didn't show you the seek P and seek G. Okay, so in order for you to work with an append, there are 2 ways you can do it, because the file pointer at the end of each file is going to be at the end. So what you need to do is that you need to reset the flags. And in order for you to reset the flags, you need to put users users.clear. This clears all the bad bits, all the bad flags if any errors have happened. And you put users.seekg 0, users.seekp 0. This is basically saying go back to the top of the file. Or what you could do is that you can close the file and open it up again. But why would you do that? That's terrible. There are ways to do it. So now check this out. We do have an error, however, that we will fix. There it is. There it is. There it is. We do have an error, however. It's not checking. It works with username, but it doesn't work with username 2 and 3. Let me do it quickly. So read line. Okay, so read line is username. Username is username 2, so it's not gonna get enter. Read line is password. Good. Yeah. You see where the problem is? You lot, are you still with me? The problem is, look at this. Look at this. Can you see it? I can't zoom in, unfortunately. Here. Here, can you see it? Can you see this thing? It's reading new line username 2, and it's technically not username 2. It's new line username. So this is why this is evaluating to false. That's why it's accepting it. So what you need to do is that we need to somehow remove that first line. Now I'm going to do something. I'm going to do some magic in here. Don't hate me. Don't hate me. Focus with me. You're going to understand. So what I want to do is I want to read I want to exclude the first letter. So what I want to do is I want the username to be equal to condition, ternary operator. You learned it yesterday. If the first character of the username, this is basically accessing the first character. This is the second character. Sorry, this is the second character, the third character, the fourth character, the fifth character, the sixth, etc., etc. You can treat it as an array. So if the first character is equal to a new line, what we want to do is that we want to construct a new string, username.begin +1. What username.begin is going to return the pointer of the first element, and we want to skip it +1. Let me just write it real quick here. Otherwise, username itself. Check this out. So it's basically what this is doing is checking if the first element is equal to a new character. I want you to construct a new string starting from the beginning +1, meaning skip the first character until the end of the string. If it's not, then you can just output the username itself. Now check this out. This is going to work. Positive. If this doesn't work, I'm not going to teach C++ again. Okay, I take that back. Yeah, I don't really need these checkpoints anymore. Continue. It did work. It did work. It did work. I'll paste. Username 0 is equal to an character string begin +1. Go on. Show me. Sign up. Enter the username 2, which already exists. Oh snap, I used username. Yeah, it's read line, not username. It's read line. Because we're removing the N from the read line, not the username. God damn it. Yeah, this is gonna work now. Yeah, the username already exists. There you go. Now if I enter something that doesn't exist, let's say for example, my man Joe, and the password is Joe, it works perfectly, and here it is. I think that's fair. I think that's fair. Now, as I promised, Q&A. You lot, any questions? Hit me with it. Okay. I'm pretty sure this is going to be a failure. You lost. Lost where? Let's get you back on track. Where you lost? If it's everything, just say everything, honestly. What's the difference between seek G and seek B? I'm not really sure, but seek G is used for import and seek B is used for output, or this the other way around. I'm not sure. Hold up. I've got ways to try it. Let me just try it real quick. So if you've got an off-stream users. Yeah, so P is for output. P is for output, which means writing into a file, and G is for input. Need to learn a bit later. Yeah, sure. Because you need to practice a bit. You need to practice a bit. What I did just here was a speed run. So you kind of need to adjust to yourself a bit. Like, you need to go around and play around with the if statements, play around with the variables, just know how it works and everything works. Just this is how check this out when you play around a bit with more, because if you learn a language for, like, let's say a week in C++, you should be able to do this. Just learn a week of C++. You know what? 2 weeks. 2 weeks of C++, hardcore C++. You can do this. Is line 76 the format if then else 76, which is the ternary operator, I suppose? Yeah, precisely. It's the ternary operator. If this is true, run this. Else, run this. Basically. Got it? Any other questions? The Cherno. Do this. Here's the Cherno. I recommend him. He's really nice. He's an Aussie. You're probably going to have a problem with the accent, but if you can understand me, you can understand him. All right. If you don't have any questions, thank you all for coming. I'll give it to Hakeem from there.